So I'd like to introduce Anwar Sadiq, who will be presenting Enterprise Cellular, improving in-building mobile cellular using CBRS Neutral Host Networks. Neutral, not neural. Anwar is a technical domain manager at Meta and is joining us from Fairview, Texas today. This is his first time speaking in an analog, and it's a pleasure to have you speaking with us today. Welcome.
Without a further ado, let's dive in and discuss how we can transform in-building connectivity from a persistent pain point into a strategic advantage for our enterprise. Why in-building cellular? Why we need in-building cellular? How many of us have experienced drop calls or slow data speeds indoors? Yeah, it's frustrating when you can't rely on your mobile service indoors, especially when you need it the most. This happens because either macrocellular signals often struggle to penetrate indoors, or the quality of signal is pretty bad. Even in the situations when the signal is strong, capacity sometimes is limited, hence negatively impacting productivity and satisfaction. Reliable indoor coverage is essential for business operations and safety compliance, including critical services such as 911 emergency calls and wireless emergency alerts via. While Wi-Fi calling can help temporarily, but we know it's not a viable substitute for a robust in-building system because it often falls short in terms of quality of service, reliability, emergency service support, and seamless handovers between indoor and outdoor environments. And finally, there are emerging use cases. For example, AGVs and robotics in the data center hallways that demand low latency, high quality of service, and mobility. So these can be best supported by a dedicated in-building network that we will look into in the upcoming slides. Next slide, please. Legacy methods and their challenges. So to improve the indoor coverage, historically, enterprises have relied on conventional solutions like off-air repeaters and distributed antenna systems. But they face several challenges, and among those are long lead time to on-air. Deployment can take from an year to 2 years due to required CapEx investments from mobile network operators. High deployment cost because of large physical footprints, significant power needs, and dedicated backhaul requirements all drive up the cost. Complexity is another pain point because the traditional solutions, they have numerous components, including cabling, antennas, dash radios, point of interface, 5G LT radios, and basebands provided by the MNOs. These all make installation and management of the system complex. And in addition to those, those legacy methods, they have limited access to performance. No access to real-time performance data, for example, network usage in terms of data volume and call counts. The legacy solutions don't provide those insights. While 911 emergency services are supported, PSAP only receives the head-end location, not the caller's precise location in those solutions. Next slide, please. So neutral host MOCN with CBRS. To address the limitations of legacy methods that we reviewed in our previous slide, Meta has pioneered the use of multi-operator core network MOCN with CBRS spectrum. This approach enables rapid, scalable, and cost-effective in-building coverage. It's very similar to standing up a Wi-Fi network using the existing IT infrastructure. Before we go into the details, let's understand the basic building blocks of this model. Next slide, please. So what is CBRS and neutral host? CBRS stands for Citizen Broadband Radio Spectrum. It's a slice of radio frequency spectrum from 3.5 to 3.7 gigahertz in United States, which is designated for shared wireless broadband use cases. CBRS enables new opportunities for wireless communications, including neutral host and private 5G networks, all by allowing multiple users to share the spectrum dynamically. CBRS uses a three-tiered spectrum access management system, which includes incumbent and PAL, priority access licenses, which are paid licenses. They have access up to 70 megahertz of spectrum. Whereas general authorized access, GAA, enterprises like Meta have free access up to 80 megahertz of spectrum, which can be used for neutral host and other private network use cases. Management access to the spectrum is enabled by an automated entity called Spectrum Access System, SAS, which communicates with the radio nodes and grants spectrum access for usage within a geography. What's in it for enterprise for this type of a model? Enterprises can use this spectrum to improve indoor connectivity by deploying a neutral host network in the areas that public macro networks struggle to reach. And a neutral host is a shared model where different operators use a common radio access network, but can still maintain separate core networks to serve their customers, ensuring subscriber identity and policy enforcements. This model also applicable for small, medium, and large buildings, and allows for easy future expansion and addition of new devices and services with minimal disruption. And it does have the ability to add a private network on to the existing neutral host infrastructure, which is already available. Next slide, please. Just making sure. Okay, so MOCN CBRS Neutral Host Network. This diagram describes the various components of the architecture. In this architecture, enterprises such as Meta deploys in-building small cell radio access points, also referred as CBSDs or cellular APs within the buildings in the desired locations. These APs These cellular APs are very similar to Wi-Fi access points in terms of their form factor. There could be multiple access points in a building or floor depending upon the RF design. And these cellular APs connect through Corp LAN to a MOCN gateway, which can be hosted in the cloud or in the public cloud or in private cloud. It is at this demarcation point, MOCN gateway, that each MNO traffic is split and securely transmitted across the public internet to each MNO's core network for user authentication and ultimately provisioning of mobile network specific services. If you notice, these devices as cellular APs, they connect to LAN switches, and those LAN switches should be able to provide power over Ethernet and support precise timing protocol PTP by distributing timing information from the GPS. These PTP devices are typically deployed at each building or in some cases shared across nearby buildings if it is a campus environment, and can be deployed indoors on a window or on a rooftop for distribution of the timing information. MOCN gateway is another piece, which is a software deployed on a VM in the data center. The main job of the MOCN gateway is to route traffic from mobile phones to each user's mobile service provider and vice versa. This allows users to bring their own phones with their own MNO subscription plans and seamlessly operate within the buildings. There can be multiple instances of this gateway depending upon the capacity and latency needs. We have these instances deployed in the West Coast and East Coast data centers to serve the respective campuses within our environment. Network management, each network element is integrated into Meta's internal management and monitoring system using APIs. While vendors offer cloud versions of their management system, we have elected to host management systems on our private cloud because of readily available infrastructure. Network Manager has also a function called domain proxy. Domain proxy is a secure interface to the SAS, which manages the CBRS spectrum. It provides key information such as exact location and other technical radio characteristics to enable the SAS to allocate CBRS channel within that geography. At Meta, for this application, we're using GAA, General Authorized Access Mode of Operation, which allows us to utilize up to 80 megahertz of spectrum. While user requirements vary on a location basis, we have determined that the GAA tier provides more than enough cellular capacity and performance. In fact, we are using only 40 megahertz of spectrum out of 80 megahertz available. Next slide, please. Meta's CBRS Neutral Host Network. Let's now dive a little deeper on how this works in reality. Let's say this is a campus with multiple buildings, with each building having a number of cellular APs and a PTP grandmaster connected with the power over Ethernet switch. Initially, when it is powered on, AP and PTP grandmaster get IP address from the DHCP server like any other IP client on the network. Cellular AP establishes a secure management tunnel with management controller, ACP. In the case of our network, we only have IP6 addresses being allocated due to the scale of our network. But cellular AP traffic is being isolated from all other kind of traffic on the shared network using the unique VLAN. So we have at this point one IPsec tunnel connected to the controller. Once that has established, cellular AP sends another SNMP trap to the ACP controller and receives the IP address of Moken gateway. A second IP address, IPsec tunnel is now established at this point. Once AP establishes an IPsec tunnel to the Moken gateway, a firewall rule enabled, allowing traffic between the Moken gateway and MNO respective cores. Moken gateway establishes a secure IPsec tunnel to the participating MNO core networks, enabling S1 connectivity to support different cellular call flows. At this point, MNOs can perform regulatory and functional tests to verify the site readiness for an MNO PLMN transmission, such as UE, attach, and verification of other services. And if everything goes well, the site can go live at this point. To ensure integrity and security, we have both users and management traffic in two dedicated IPsec tunnels. So we have an IPsec tunnel from AP to the controller for management, another IPsec tunnel from AP to the Moken gateway, and then towards MNO core for the user traffic. So this was done to ensure that Meta does not have any access to the MNO cellular data while in transit, further strengthening the security environment. Next slide, please. Private network on a shared platform. Another benefit of this model is the ability to add private network using the same infra, which is being used for the neutral host. This will entail Meta-issued specific SIM cards, allowing secure, high-quality connectivity for various applications such as remote security cameras and other AGV type of applications. This means that if a device has Meta-issued private SIM, it will connect to the same network and can be served from the edge, reducing latency, all by keeping the application data local instead of traversing through the internet. So it provides low latency and local breakout of the data. This is specifically important for applications which require low latency and have requirement to keep the data local instead of traversing through the internet. And on the same network, if a user has a public SIM from any of the participating mobile MNO, it will be routed towards the respective MNO core seamlessly. Next slide, please. If you can please go back to the previous slide where we have scale and impact at Meta. So at Meta, we focus heavily on the quality of service available to our employees and visitors, and seamless connectivity across the properties become important. Over the past couple of years, we have deployed Moken-powered neutral host networks in 30 plus facilities across US, covering 9 million square feet of office space and serving about 50K users. And the network is fully operational with all three major US MNOs and is delivering improved user experience, safety, and productivity. On average, the network handles roughly around 25K users and handles our 10K calls daily with an average throughput of 120 down and 30 megabits per second up. Next slide, please. So I just went over on the private network. It's just showing that if a user has a private SIM, it can ride onto the same network, and then Moken Gateway will route the traffic to the local core without traversing the traffic towards the internet. And if a user has a public SIM using the same network, Moken Gateway will route the traffic to the respective MNO core. Next slide, please. Key takeaways. Moken neutral host model solves in-building coverage challenges that have plunged enterprise networks for years. It offers mutual benefits to both enterprises and participating MNOs. For enterprises, it means lower TCO through savings in head-end space, power, and cooling requirements, and by leveraging existing LAN infra. It also eliminates the need for a dedicated backhaul because now you can use a shared backhaul for the network. In addition, it enables faster deployment, scalability, and comprehensive network visibility, including access to performance KPIs, which are not available with legacy solutions. And as we looked at in the previous slide, the same infra supports private network addition for the different use cases which may require low latency and local breakout. For MNOs, it means no CapEx investment. So it's an attractive model for MNOs as well, that MNOs, no CapEx investment needed for signal sources and basebands, unlike the legacy approaches. On the left hand side, I took a snapshot from one of our deployment, which shows that with the legacy solution, there were 4 full racks of equipment which were required to bring the system on air. And on the right side, the CBRS deployment, no new rack addition was needed. Only the Ethernet cable is going into one of the existing switches, which of course are PoE enabled. So it reduces the space and power requirements almost by more than 70%. Next slide, please. Deployment process. So let's take a quick look at, next slide, please. Yeah. A quick look at the deployment cycle. It's a 4-step process. Step 1, identify the building and perform site survey, which includes RF baseline assessment, identification of IDFs and cable pathways, and install location for the timing PTP. If the PTP grandmaster is able to lock to the GPS indoors, it can be installed indoors on a window. Otherwise, outdoor rated versions are also available for distribution of timing information. Step 2, the survey input goes to the design, which is typically completed in widely industry accepted tool IBWave. The output of the design includes CIQ and AP locations, which is then shared with the MNOs to provision the PSAP for emergency services. I'll come back to more details in the coming slide on the CIQ, that what information is needed to be shared with the MNOs to enable the services. Step 3 in the deployment process is once the design is complete, install the APs and PTPs, provision the AP for SAS and MOCN connection of the APs. Step 4, MNO activation. If the site is already being added to an existing MOCN instance, no new S1 setup is required. Means MNO can schedule PSAP testing, and after successful test, the site can go live. If the building is being added into a new MOCN instance, some additional time is needed to exchange the certificates and set up a S1 connection with the MNOs, with their security gateways and MMEs. In all, network can be in full service with 12 to 16 weeks time frame. And we have worked with different partner MNOs and have activation SLAs with MNO partners, which ensure the smooth on-air process. Next slide, please. Let's look at the case study. We have a building about 50,000 square feet, 2-story building in downtown Pittsburgh, where indoor coverage was very poor, resulting in dropped calls and poor user experience. The chart, the snapshot on the right side shows the output from the design tool with showing 3 cellular access points connected with a PoE switch inside the IDF closet. Design and install was completed in 4 weeks, and network configuration, MNO provisioning, and testing was completed in 6 weeks timeframe. And network was fully functional within the 10 weeks timeframe. Next slide, please. Here is an example of CIQ. CIQ is basically a set of inputs, customer information questionnaire. It's a set of inputs which is generated from the design and shared with MNOs to provision their systems and PSAP for PSAP handling. It includes AP name, latitude, lat long information, and height info, along with which MOCN gateway it is going to be served from, which is used by MNOs to connect with their security gateways. And since each floor can have multiple APs, this information enables precise identification of the call's origin location in case of emergency, compared to the other legacy solutions where call goes to a hidden location, which could be in a different building, which is a problem for the emergency support. Next slide, please. This chart is showing before and after comparison, showing improved coverage for each of the participating MNOs. Left-hand side is the before deployment. Blue and red colors show poor coverage and gaps in the coverage, whereas on the right side, it's showing improved system with better signal quality and quality of experience. And the whole network was fully on air in 12 weeks time frame. Next slide, please. Network visibility and performance. Next slide. So to manage any network, visibility into network's health and performance is essential for operations and management. Since the enterprise, in this case, controls the AP and the MOCN software, enterprise has the full visibility and access to the performance statistics, either directly from the APIs or through the flat files. At Meta, we use internal tools and APIs and have built dashboards for the real-time network monitoring and statistics. So this setup allows to accurately track which cellular APs are live or out of service across the whole network. Next slide, please. In addition to health of the network, this model also allows access to the full performance KPIs. That means enterprise can have full access to performance KPIs such as availability, usage of the network, tonnage, data usage, number of calls flowing in the network, and also the call drops and the different other network KPIs. And this becomes useful during the events, or if we have to support the events, high capacity events in the indoor environments. Next slide, please. So with that, we come to the best practices and design choice. So like any other, next slide, please. So like any other deployment, there are design choices that are to be made. At Meta, we have ensured implementing the network in a way that is seamless to the mobile users, allows the MNOs to maintain the relationship with their subscribers, and enterprise should select the deployment model that aligns with their specific requirements. In case of Meta, we are using shared LAN deployment approach, which lowers the total cost of ownership because we're going to share all the LAN infrastructure, but it does increases complexity and dependency on the core network. So while making that decision, it's an important factor to decide whether we want to use the corp network, existing network, or we want to have a air-gapped network. Our approach, our recommendation is to use, if in case of shared LAN, use the dedicated VLAN for cellular APs and implement dedicated IPsec tunnels for both the user traffic as well as the management traffic for the control purposes. In addition, PTP Grandmaster, the timing source can be shared across buildings if it is a campus environment, and it can be installed both indoors or outdoor on the rooftop. IP version 6 is fully supported, and we also recommend using a security gateway for managing the internal IPsec tunnel for the management purposes. The deployment of Mokon software, again, it can be deployed on the public cloud or private cloud. Each has its own pros and cons, and at Meta, we have it on our private cloud due to readily available infrastructure. Next slide. Collaboration with MNOs. So close collaboration with participating MNOs is essential for successful implementation of this model. It's important to have set up a master agreement that includes activation SLAs and standardized process for adding new buildings, and have day one readiness and day two operations clearly defined on those service agreements with the participating MNOs. Clearly define the roles and responsibilities for ongoing support in case of production issues on day two. Have a change management process fully documented with each MNO, establish processes for software upgrades and network changes, as adding or relocating APIs do require notification to MNOs because of the PSAP emergency compliance requirements. Next slide, please. Security, network security is of the utmost importance, and Mokon model is no exception. We recommend using certificate management protocol CMP2 for exchanging certificates and their auto renewals while setting up the S1 interfaces with participating MNOs. And also for operations, only allow role-based access for internal operations. And management traffic, try to have it in two dedicated IPsec tunnels, separate with user traffic. Next slide, please. And finally, for effective management and operations, we recommend to build a unified dashboard for network visibility and management of all the elements through a single pane of glass that helps in the network operations. Next slide, please. So that concludes my presentation. We can open the floor for questions and take questions here.
Please come up to the mic or put your question in the remote Q&A. If there are no questions, thank you, Omar, for your talk. That was great. Thank you.
Thank you all for your attention. And my colleague, Dino Thomas, is attending in person and will be happy to answer if there are any questions. Feel free to reach out to him.
All right.
Thank you.
Thank you again. We really appreciate your contribution.
Thank you.
Okay.